Alright, welcome back to part 2 of this video. So we're going to be looking at more now of the qualitative analysis of various solutions or compounds in order to figure out kind of what they're composed of or what ions might be in that solution or compound if we aren't too sure. So these are called qualitative analyses because we are not going to be doing any calculations. These are all going to be just visual observations or kind of just narrowing out some options in order to determine what a compound is composed of. So the first test that we can do, specifically if we have a solid compound of any variety, could be a metal, could be a compound, is something called a flame test. And that is for solids or metals. So as the name suggests, you simply light it on fire. And once you light these things on fire, what is going to happen is various things are going to burn. So various ions burn at different colors. And knowing this, we can take an unknown compound, ignite it, and see just exactly what it produces. And this is actually one of the main things where we realized about the sun. So when we had the sun, we've never been able to go to the sun, and we never will, because of A, the heat, and B, the gravity. It would just pull us in. So how do we know that the sun is composed of hydrogen, or mainly hydrogen? Well, this is just simply based off the color. So we're able to use some spectrometers and wavelength spectrometers to determine the color that is burning from the sun, right? So this is just hydrogen ions, so just H2 or H plus ions that are burning. And they give off that kind of yellow-orange looking color. So we're able to determine that hydrogen is what is on the sun, or a main component of the sun, without actually ever going to the sun. And we can do this with a variety of other compounds. So various ions are obviously going to have different colors that they're going to burn at. So here's just a list of a variety of ions. We don't necessarily know a lot of them for more reactive metals, A, because they're less available, and B, because they will be quite reactive and could potentially be dangerous. So lithium is like a crimson red. It's almost like a bit more of a burgundy red kind of color. Sodium will burn at a yellow orange kind of color. I only had a few markers, so I tried to make them close enough. Potassium will burn like a lavendery purple color. Cesium will burn blue. Calcium will burn like a red orange. That'll almost look like a little bit like a campfire. Strontium is a very bright red. So it almost looks, it's a really cool color actually. Barium will be a yellowish green color. Copper will burn at a blue-green, quite similar to the color of the solution that we saw when we dissolved copper 2 chloride. And lead will burn at a kind of a lighter blue, almost like a blue-white color that you might see at the bottom of your Bunsen burner. If you ignite it and have the correct amount of oxygen going through, you'll see that kind of blue-white flame, and that'll be pretty similar to lead. So in a variety of different compounds, we can use these characteristics in order to burn them and determine what they could be composed of. The next thing we can look at is colors in solution. So like we saw with our copper 2 chloride solution, some solutions have very distinct colors. And so using some of those colors, we can determine, or maybe not determine, or approximate what that solution is composed of. And this can kind of guide our process in order to determine more specifically what things are composed of. So we'll see at the bottom of this page here that a lot of things are in solution at very, very similar colors. So chromium and copper, they're both going to be kind of a darkish blue color. Chromium 3, copper 1, iron 2, and nickel 2 are all going to have a green color. Iron 3 is going to be yellow along with chromate. Cobalt 2 and manganese are both going to have a pinkish color. Permanganate and dichromate are both going to have a purple and a orange color respectively. So although these aren't going to tell us exactly what's in a solution, it might be able to guide us so that we're able to determine a little bit more specifically what could be in there, or allow us to do different tests in order to specify exactly what's in there. And one of those tests that we can do with solutions is we can actually use precipitation. So as we know, in double displacement reactions, a lot of the times a precipitate will form. So here we kind of show a process that we can follow in order to determine what type of solution will be formed. So we could have some solution of unknown ions we might not know, and we could add something to approximate what we're going to have in that solution. So we can look here and go, okay, there's a precipitate formed, but there's still going to be ions left in the rest of the aqueous solution up here. So what we would do is we would filter that out, right? Take out all of our precipitate and just leave what we have left in our remaining ions that are still dissolved in solution. And then maybe we add H2S, and maybe we see another precipitate form, and then we still have some ions remaining in solution. So what this can do is it can slowly eliminate various things from our solution so that we can actually have a better idea of what might be composed in that solution. And we can do that using our solubility charts. So in that first reaction where we added HCl to the reaction, or an unknown batch of ions, right? What we will see there is that the chemical reaction is actually going to be, let's just say we have our Cl minus, if we write a net ionic equation, and it is going to react with some cation. So I'm just going to say A plus. So it's going to react with some cation. And that is going to produce a solid precipitate of A, or Ca plus and Cl minus, right? And they are going to form a compound. So if we look at our chart here, our solubility chart, right? Almost everything is soluble when bonded with chlorine. So the one that comes to mind is sodium. So if we had sodium in this solution, we're not going to see that precipitate out. So the only 5 things that are going to be insoluble or have a very low solubility when bonded to chlorine are going to be silver, lead, mercury, copper, and titanium. So knowing that, we can guarantee that this precipitate here is going to be one of these 5 things bonded to chlorine. So it could be AgCl, it could be PbCl, could be HgCl or HgCl2, CuCl, or titanium chloride. Right? So we know that that precipitate, we can narrow it down to be one of these 5 solutions, or 5 compounds. Right? However, if we want to look further, and we're not really interested in what the precipitate forming is, maybe we're interested in what these leftover ions that are still in solution are. So we can add something else, H2S, and that would give us a net ionic equation of S minus plus A plus, again, so another just cation, in order to produce, if this is an S2 minus, sorry, right, that is going to produce an A 2s, right? If it is a single cation. And if we look down on our solubility chart, sorry, it's a little bit messy, but we know that in solution, solubility is going to, sulfur is soluble with H, NH4, beryllium, magnesium, calcium, strontium, and barium. So we know that this up here has to contain one of these 7 entities. However, anything else, right, any of the other components are going to be formed in a precipitate, right? So it will be anything other than these values. And if you continue to go through this, obviously this is a little bit general, but we can combine this with, say, our colors of solution. We can start looking at these and go, okay, well, my solution is green. So I know it's probably going to contain either chromium, copper, iron, or nickel. So if I look back here on my solubility chart, and I know it might contain chromium, copper, iron, or nickel, well, one of the low solubilities with chlorine is going to be Cu. So I can guarantee, based off of combining this observation with my observation that a precipitate formed, that this precipitate must be, it will be copper chloride, right? So it's interesting how we can start combining all of these 3 things together, right? We can start looking at the colors, using some precipitation in solutions in order to determine really what these solutions are composed of. But ultimately, when we look, we're going to spend a little bit of time with our qualitative. However, quantitative is going to give us much more information. So qualitative is a lot more so just determining what is in a compound or having a good idea of what is in a compound. But quantitative is going to be much more specific, right? We can do quantitative analysis, so say using our solution stoichiometry, which we were going to be doing tomorrow. Right? In order to figure out exactly what those solutions are composed of, and exactly how much of those as well. And it may not just be how much, it may be how much we require. There's a variety of different situations where we can use quantitative analysis in order to really specifically understand what is exactly going on in our solutions. So that is about it for today's lesson. Feel free to go back over the videos if you're stuck at any points. And obviously, if you have any questions, send me an email. I should be available tonight in order to answer emails, or even if you send me one throughout the day, I may be able to check my phone while I'm on the bus. So please do not hesitate to send me an email if you have any immediate questions. If not, ask me on Monday at lunch. But for the remainder of class, depending on how much time is left, go to page 414. There's just some review questions, and I've outlined 7 of those questions that I think that they might be helpful for you to complete. So use your time wisely. Spending a lot more time with this stuff is going to make it much more easy when it comes up on a test or an assignment. So complete questions 1, 2, 5, 9, 10, 12, and 14. And even if you have some time tonight for homework, just kind of look through these questions. I don't think they'll take you too long. But again, if you have any questions, please let me know, and tomorrow we will be going over a video on solution stoichiometry. All right, so have a good night, and you will see me again on the video tomorrow.